Saxon Advanced Algebra, Lesson 69. We have a fun little lesson today that's going to make you feel very smart. We're going to study the Matrix. No, not the movies from the late 90s and the early 2000s, but just as cool. A matrix is an arrangement of numbers. And we can shorthand the word arrangement to say it's an array of numbers or symbols, because we can use letters, into a rectangle. And I'll show you some in just a second. So it's an arrangement or an array of numbers or letters into a rectangular shape. Here we have some lovely examples. My light's kind of far away. Hope the other guys could see. These are all matrices. That's the plural. Okay, so this is considered a 2 by 3 matrix because it's 2 rows by 3 columns. This is a 2 by 2, this is a 2 by 4, etc., etc., etc. D is a 2 by 6 matrix, okay? Notice that, okay, here are some with letters. These all have numbers, it's fine. Notice that some of them are just the numbers themselves. Sometimes we put, I guess John doesn't have any of those. Sometimes we put straight lines along the sides of them, or sometimes we put these sort of squared off parentheses. Okay, those are the 3 different ways of showing that something is a matrix, but we get this really distinctive rectangular style. The numbers within the matrix are called elements of the matrix. They're arranged neatly. All rows must have the same number of entries, and all columns must have the same number of entries. So in other words, you can't have holes in your rectangle. You have to be filled in completely, okay? 2 matrices are equal if the entries in one matrix are identical to the entries in the other. So A and B are exactly the same, but C is a little different. So C is not equal. These are the same. Okay? That is what makes a matrix a matrix. Now, we're not going to study all matrices. We have a special fascination with the square matrix. Obviously, that's a situation where the number of rows equals the number of columns, right? And we're going to be looking mostly at the 2 by 2 type matrices. And anytime you have a square matrix, you have something called a determinant. That is a fancy $5 word that means that it's like the answer to the matrix. Okay, there's an implied calculation in there that we're going to unravel in just a minute. And the determinant is the name of that answer. Now, here is an example. Now, John just wants to show you, though. We're going to solve this matrix first. It's 4 times 2, no. It's 4, 2, 3, and 5. Notice the pattern. And these are the 3 different styles of presentation. No lines, plain lines, bracket lines. All right? I like to draw mine with the straight lines. So what I'm going to do is I'm going to write 4, 2, 3, 5. I won't always make them this big. Okay? And then we're going to solve for the determinant. And here's how we do that. Oops, I spelled that wrong. We start here and we multiply down. 4 times 5. Then we're going to subtract 2 times 3. All right? And so our answer will be 20 minus 6 equals 14. Did John show us that? No, he didn't. But that's the answer, okay? Now, the trick is to remember this pattern. We start here, we go down, we go there, and we go up. Notice that, I don't know if I had any of you guys when you first learned to cross multiply, but we've been cross multiplying. This is exactly how I teach my students to cross multiply. Start here and go down, start there and go up. And the reason why is because if I can ingrain that process in you from the very beginning, then when we get to solving matrices, your brain will already find that a very natural association, a very natural way to go about it. John gives us another little tip that's kind of fun. He says, think of a map of the continental United States. And these 4 locations, hang on, Grace, you can't cry right now. Think of those 4 areas as the 4 locations in the matrix. We start in Seattle, right, because we live here, and we go down to Miami because it's sunny and warm, because so we want to go down there, right? As long as we're down in the sunny land, we go over here to Arizona, and then we go up to the negative. And up to, I don't know, looks like Nova Scotia, honestly. But what we have to remember is it's this minus this, okay? So we're going to practice, and let me just do this. This will help. A. Again, I want to do it exactly the way John does it. A, B, C, and D. Then we can write it as a formula. A times D minus C times B. So this is kind of a generalized way we can remember how to do the multiplication. Hang on, my dog's aping. Is someone eating? Grace, come back. Come on. There's no food for you. Sorry, I abandoned you. Around this time of night, my daughters often come down and have something to eat, and she goes in and tries to mooch from them, and they feed her treats, and it's all a happy time. But sometimes they don't come down, and she's sure that they should be down here eating, but they're not. Okay, so what we're going to do is we're just going to take this process and work a few problems with it, and that's the end of that. Okay, that's the end of this lesson. All right, notice I got a new book for you guys. We filled up yet another one of our big ones, and I have a whole bunch of these really fun decomposition notebooks, so I wanted to use one for you guys. So we're in a cozy little house in the woods, and I'm enjoying it. I don't know about you. I'm feeling the vibe. I have to fold them over in order to get them in front. The pages leak a little bit with my marker, but that's okay. I'll just use the front side, and that'll be better anyway. Okay, let's do another one. That one that I did was just like made up. Okay, ready? Minus 4, 2, minus 3, 7. Okay, so that's going to equal Seattle to Miami. That's minus 28. Minus Arizona to Halifax. And that is a minus 6, right? The only thing that's confusing about these is that you multiply and then you add. And that sometimes is a little bit crazy making. So this becomes minus 28 plus 6, so that's minus 22. Let's do another one. They really don't get any harder, you guys. You just have to keep track of the minus signs. My dog's out there causing trouble. Seattle to Miami is positive 28 minus Tucson to Halifax, 15. All right. Oh, this is all example 69. Sorry, I'm writing 5s as if we were 10 lessons in history. False. 69.3. Okay, this gets a little bit more interesting because look at this. All right, so Seattle is x plus 2. All right, well, let's just do this. 4 times quantity x plus 2 minus 2 times 3 is 6. And we're supposed to find Oh, and then it says, just a second, and then equals 18. We would need to have that so we could solve it. So now this equals 18. This was part of the problem. I didn't write it down at first. We distribute 4x plus 8 minus 6 equals 18. Combine that and we get plus 2. So I'm going to subtract 2 from both sides. 4x equals 16. Oh, John. X equals 4. So we can have fun little... Oh, wait a minute. Did I copy something wrong? Did I do something wrong? What? This isn't the right answer. Oh. I see. The actual problem said x plus 4 here. But that's okay. Just do it my way. It's fine. We got it right for what we did. All right. And one more. Grace is out running around the house. Doing Lord knows what. Grace! She was upstairs. Last problem for this lesson. Okay, find x. Good girl. She came back. Okay, so again, we have an equation to solve, which we're going to need because we're going to have to deal with these x's. And look, this time they form a binomial, right? Quantity x plus 4 times quantity x plus 2 minus 3 times 5 is 15 equals minus 5. Let's add 15 to both sides. And we'll get... That cancels. That becomes positive 10. Now, let's multiply this and see if we can work a trinomial out of this, right? It would be x squared plus 6x plus 8. Then we'll subtract the 10 to bring it back over. X squared plus 6x minus 2 equals 0. Okay, now we have to factor this. Well, I don't know about you, but I'm pretty sure I can't think of any two numbers that multiply to minus 2 and add to positive 6, which means we have to either complete the square or use quadratic formula. All right, let's use Mr. Quaddy because we haven't used him in a while. X equals minus b plus or minus. See if you can do this without me. There's our formula. A is equal to 1, B is equal to 6, C is equal to minus 2. Right? Give you a chance to catch up. Now remember that because of all the minuses in here, I'm going to be really careful. I always use buckets for my letters. So I'm going to rewrite this, putting in a bucket everywhere there's a letter. And then I'm going to put in my A's, go there. My B's go here. And my C, with the minus sign, goes just in that one place. All right, now I like to simplify inside of this first. 6 squared is 36. And then it's going to be plus 8, which equals 44. Oh, that's a 6. Okay. So now I've got, and then this, oh, well, let's just do this. Minus 6 plus or minus the square root of 44 all over 2. Oh, that came down really fast, didn't it? That looks good. I would like to be able to cancel these, but I would need an even number to come out of that pig house so that I would have something to cancel against. And I see that's going to work because 44 is 4 times 11, and I can take that out as a pair of 2's, right? So that means I'm going to have minus 6 plus or minus 2 square root of 11 over 2. Now these guys, and so, okay, so effectively what I'm going to do is factor out a 2. So it'll be 2 times quantity minus 3 plus or minus square root of 11. See, I don't want to cancel yet because I have to factor first. So I'm pulling a 2 out on the top, and then I'll be able to cancel to the bottom. So minus 6, I divided it by 2, I get minus 3. This, I take the 2, I leave the square root of 11, and now it's over 2. So now my final answer, goodbye, goodbye, x equals minus 3 plus or minus square root of 11, and that is our final answer. Now, John takes this 1 more inch. I mean, maybe it's a mile. This is the right answer. We solve for x. But what John does next, I'm not going to do it because that's just crazy. This is the right answer. He asked us to solve for x, find x. But what John shows us we can do, if we are so inclined, is we can take this value and plug it back into the original matrix, right? Notice this is minus 3 plus square root of 11. There's going to be 2 of them, right? One for the pluses and one for the minuses. So the 4 combines with the minus 3 to be 1 plus square root of 11. And then down here, I'll combine it, and that'll be minus 1 plus the square root of 11. And then he's creating another matrix for the subtracting the negative version of this. So then it would be 4 plus square root of 3 is positive 1 minus square root of 11. And plus 2 minus 3 is minus 1 minus the square root of 11. So we can recreate the matrix without the variables by plugging it in if we want. And then what John also does is he tests it and sees that if you multiply that times that and subtract that times that, both of them will have a square root of a value of minus 5. That's going above and beyond. There's our answer right there. But we can continue on that work, and I would guess in the homework you may have to do that sometimes. But that's all for our lesson today. Goodbye, goodbye, goodbye.